My research interests include measuring the response of harmful algal species Karenia brevis, which is known for Florida red tide, and Pyridinium bahamense to rainfall and also urban stormwater runoff. More specifically, dissolved organic matter in both of those sources. And the reason why I'm interested in dissolved organic matter is because that can be both from human inputs and natural inputs. Natural inputs being leaf litter, soils, grass clippings, and even pet waste, and also anthropogenic inputs or human inputs, which can be synthetic fertilizers that we put on our lawns, pesticides, any drippings from our vehicles, and essentially all of that gets washed away via stormwater runoff and ends up into our coastal water bodies. And I'm interested in seeing if they can influence bloom severity. My background is harmful algae. I started out researching red tide at Mote Marine Laboratory in the Red Tide Institute, where we focused on mitigation. So finding some type of a compound that can not only destroy Karenia brevis cells, but also the toxins. And that's one of the reasons why Karenia is so harmful, is because it is a toxic hab and it creates these massive fish kills, and it's really detrimental to the environment, but also human health. So these toxins are called brevetoxins. They can become aerosolized and we can breathe them in. So really problematic also for our economy. And Florida's coastline really drives our economy, and we want to keep the waters bloom free. So instead of mitigating it by adding a compound, I was really drawn to thinking of what can we do land-based to prevent these blooms from being so severe. And one of those things is mitigating nutrients. The question is not can we eliminate red tide, but can we make it less severe? And one of those ways that I'm hoping to shed some light on water quality is looking at improving stormwater quality so we can prevent these blooms from being so severe. I was originally a HAB scientist, or harmful algal bloom scientist. Now I'm dipping my toes into stormwater, which is more of an engineering field, and also learning more about land use and specifically in an urban sense, how urbanization can impact water quality. So there's a lot going on when you have this interface from land to sea or land to estuary. And it's challenging, but that's why it's so interesting to me, because they're two completely different ecosystems, and a lot can happen in between in terms of blooms of harmful algae. This is called the HAB Hangout. Essentially what I've been doing for the past year is growing up algae so I can introduce them to stormwater and measure growth response. So I've been growing Pyridinium bahamense, which is a harmful algal bloom species that is known to make massive blooms yearly in Old Tampa Bay. It's toxic. It produces saxitoxin, which can bioaccumulate in shellfish, so that's problematic because you cannot harvest shellfish when we have blooms of Pyridinium bahamense. It's also known to be one of the deadliest HABs because it only takes a small amount to have some really horrible effects on human health. So the state of Florida does monitor it really closely, so we don't have to worry about that happening. I also grow Karenia brevis, which is known for Florida as Florida red tide. It produces brevetoxins. Those toxins can also bioaccumulate in the environment, so in shellfish, in fish, and hierotrophic organisms, and that's why we see some really negative impacts in fish kills and sea turtles and dolphin, even seabirds when we have these severe red tide blooms. But also the impacts to human health via aerosolization of these brevetoxins through sea spray. Growing them up, and now this stage is introducing them to two things. I wanted to see response to just rainfall before it hits the ground, and also stormwater runoff. So I collect stormwater runoff at several sites in Pinellas County. I monitor those sites for nutrients, and for this study I'm looking at the difference between the response of coastal stormwater runoff, so a beachside runoff signal, and a mainland urban runoff. Because both of those I hypothesize are chemically different because you have different land use. On the beach, we have very manicured turf lawns that are small, and these houses are very densely packed in, and then you have condos and high-rises, and that chemical signal will most likely differ to the mainland sources of runoff, which will potentially have more oak leaves and other types of plants and more soil inputs. So the goal here is to isolate which chemical compounds in the dissolved organic matter pool can stimulate blooms. And again, stormwater typically is measured for inorganic nutrients and water quality in general. Organic isn't really focused on because it was thought up to this point that algae prefer inorganic because it's easier to take up. While that's true, they can still utilize organic sources of nutrients. So that's why I want to dig in deep and see which compounds specifically we should focus on, so then we could potentially do some type of a mitigation protocol, removing those compounds from stormwater before they enter the watershed.